Hello and welcome to Cooking with Unity. I'm your host, Maximilian Moreau, and with me is my tech, Philip Wilson.
Are you ready for an exhilarating trip through programming?
Yeah, are you? You better
so.
be, because we're going to be doing some exhilarating programming. So, on our last episode, we were playing around with time as a variable, and we have this little game system here, and we have it so that we have a few different objects of different types, and when you go into the red box, it slows time down. And you can hear the audio slows down as well. And if I can get out of here...
Yeah, it takes a little bit of effort to move out of the time slowy box.
We can speed up time, and time speeds up just fine. Actually, does it?
It does speed up player movement as well.
So, that's what we got. So, on the last episode, I said we might touch on reversing time, and on the news post I said it's likely we're going to touch on it, but we're not going to do it, and I was right. We did some more experimentation and doing some stuff, but I want to show you the difficulties involved and the theory involved, and maybe you can create your own system and stuff. It's just something that we can't really do in an hour, and we can't really do in 5 hours. It would be easier, honestly, for me to write a component and just give people that than it would be to show on the show how to get everything working. And it still wouldn't be easy for me to do that. So
it is quite the lofty task.
So what the problem is, so let's just do a quick test. We're going to take one of our cubes here, our slow down time cube, and we're going to set this to -1.
Negative
1. So the new time scale is -1.
Awesome.
Whatever. So when we go into here, you'll see that the sphere that was rotating clockwise starts rotating the right direction. The cube that was moving one direction reversed properly. The physics object we have here, this little thing, stopped completely. The particle system stopped completely, and the player has stopped completely. I can't move the player in any way, shape, or form. But these two ones are actually working, and they're working backwards, even. So what's special about these? So this one is an animation object. Animation objects actually support negative delta time. If your time scale is negative, it will extrapolate everything backwards from that point. Mm-hmm. In the case of the sphere, we're using a circle move script, and this just uses, this is our own script, and it uses time.deltaTime as a variable. So all that's happening here is this is getting, time.deltaTime is now negative, because time.timescale is negative, and so this will just effectively get smaller. T will get smaller, and so everything reverses properly. So already we have three complications. So the player doesn't work anymore. Yep. The physics objects don't work anymore. We only have one as a test case, but I guarantee it will not work for any rigid body. And the particle system does not work. And there may be other systems that don't work as well. So already we're in a bad situation. So let's talk about why these things don't work real briefly. So in order to go back, everything has... So in the case of circle move, this is a reversible operation because all it is a multiply of time.deltaTime, and it'll just work. The code doesn't have any intricacies that make it so that that's difficult. This is not always the case. In the physics system, most physics systems, I say most, but I'm really not sure at this point, don't support going back. And it's because they only store the state information that's necessary for figuring out the next frame, and they don't store the state information in a way that's useful for figuring out the previous frame. They would either have to keep track of at the very least the previous frame if you just want to be able to reverse time at a 1.0 rate, like -1, and they have to keep track of an arbitrary number of frames for different speeds above that, or they would need to have a system where each frame has enough information to reverse the operations that would be going forward. And it's possible to do that. Braid, I'm pretty sure, uses a system like this, where it actually makes sure that all of the components are discrete and reversible. So everything that happens the same way no matter what. Like if the state's the same, it will happen the same way. Mm-hmm. And it will happen the same way but reversed in the backwards scenario. We don't have the luxury of reprogramming the stuff that's built into Unity. So if you want to do a system like that, you have to make sure to manage everything yourself. And as you can see, you could do something like that because Time.deltaTime will properly reverse, and so you could just set up all your objects and do all your logic and not use any of Unity's physics system, particle system, and any other systems that don't support time underneath 0. Now, that solves everything for the world, assuming that you don't use those objects or you replace those types of objects, and you can reverse everything. You still have to be able to reverse the player. And that's a little bit trickier because the player, you don't know what he has done unless he's currently doing it. We don't store that. So you have to store that information. That is something that has to be recorded. Or at least the results of that information have to be recorded in some way. So what that means is, at the very least, no matter what, we need a recording system for the player if we need to reverse the player's actions in a game, and we want to have support time reversal, which means that we have to basically take everything about the player, or everything that the player has done, and record it, and then replay it as input, or replay the positions. And you could also use this to solve the other problems. So, like, if we record the state of every single object in the scene, like if each of these objects, we were recording all of the states of all of their scripts and systems, we could theoretically play that information back or reverse that information and just go to that frame and just reread that information, and then everything should work forwards from there. If you go back again, you just go to the next frame back or whatever until you run out of frames.
Yeah.
We actually had a system that we were working on to do that. We were using a serializer. Actually, I'm going to show it real quick on the asset store because this is actually a really great serialization system and it's free. Serializer. So there's a save game, JSON plus binary. This is a really great setup if you want to save the state of everything in the scene and load it later. And it can also save it to disk, and it can save it to RAM, and it can do a lot of other things. And we tried basically saving the states of information to RAM and then restoring it, but we ran into a lot of little issues and didn't have a working case for even that simple portion. So we're not going to be reversing time. But those are the type of things that you're going to basically need to do. You're going to either have to record everything, or you're going to have to make sure that everything that you don't want to record is discrete, and everything that isn't discrete, like player movement, is recorded. Mm-hmm. So you're going to have a record system, and you may have to have, and if you want to make a really good system, you're going to want everything else to be not tied into that system because it's less to record and all that jazz. So I guess that's enough talking. So let's start by doing a couple things we didn't do in the last episode. So one of the things I wanted to show in the last episode was making the player not affected by this. So
I was going to suggest that.
So let's go into the time manager real quick. So we have a real delta time in our time manager now. And so if we go into our player... Oh, yeah, that's right. We didn't do it because we're using...
the first person.
First person stuff. Let's do it. Let's do it real quick. C# first person controller. So, character controller in C#. I think someone actually ported all of them at some point. Alright. Character.
Oh, yeah, it was in JavaScript, wasn't it?
Character controller.
Unity C#.
Unity C#. There we go. Oh, there was a... Huh. I totally found someone who had done this at one point. I'm naturally not finding it now.
Of course. That's usually how it works.
Alright, well...
Unfortunately.
Let's, Alright, well, we'll just do this. We're not going to use our fancy little thing. We're just going to change the stuff in here. So we're going to just go into mouse look. The reason that I wanted it in C# is because... sorry, it's character motor. I wanted it in C# because then we could call our class, which we could do, what is it called? Time manager. Mm-hmm. But it won't even show up in the list here because C# and JavaScript don't directly interface as far as I know, and I don't know what the details of it are, honestly. But so we're just going to multiply in it's not that much more code to just throw this in here, and it's going to be doing the same thing anyway, so we're just going to throw that in. So anytime we need time.deltaTime, alright, we'll just do a find replace. So actually we'll just do delta time and paste. Whoops. Okay, it'll be faster just to do this. Search, replace time.deltaTime with time.deltaTime times timescale all. Save that, and then we're going to go into that should be it.
Yeah.
Yeah. So we hit play, and oh, nope, didn't quite work. Oh, because time.timescale went to negative. Let's not support that.
No.
Although that should have not mattered, because time.deltaTime would be negative in that case as well, and that would cancel. Well, let's just not do that anyway and see what happens.
Yeah.
In theory, it should work.
In theory.
So we hit play, and we go into the... Nope, we still got stopped in our tracks real nicely. What are we looking at in our time manager? Time.deltaTime times time.timescale, which means that if we have a delta time, if the time scale's half, delta time will be half of what it usually is, which will double it. So that's the right thing. Alright, let's actually look for all our time.deltaTime instances and see what we've got. Time.deltaTime, time.timescale, time.deltaTime, time.timescale. Oh, I know what we need to do. So times time.timescale. We're going to search for these. There should be 8. Good. And we're going to put brackets around them.
Ah, that would do it.
Because that may be important. As a matter of fact, I'm pretty sure that's required in a lot of cases. So let's hit play. Nope. No dice.
Dead in the water. Huh.
Oh, it's divided by times.timescale. I'm retarded. Wait, but do we have that working? Does anything use this? Find in files, whole solution, find. No, nothing uses it, so that would explain why it could be totally wrong.
That's awesome.
Alright, let's try that again. So we're going to do divide by all. Save. So now we go in and...
That worked.
It didn't work entirely, right? Yeah.
No.
Still not working. It's working better, but...
Yeah. Certainly more effective at moving now.
Okay, let's think about this. I'm obviously doing something wrong. So, delta time. So timescale, let's say timescale is 50%.
Yeah.
Even though that's a magic number, and we probably shouldn't be using that as a test, but...
magic numbers work.
Alright, let's do 10%. Let's do 10%. So time.delta timescale is 10%. So 0.1. So time.deltaTime will return something that is multiplied in by time.timescale.
That should work.
And so that should undo the multiplication.
It should. Does it have to do with acceleration on the player?
Let's try. It might. That's a good question. Let's just try it one more different way.
Just order of operations?
Yeah.
I mean, sometimes the order of operations is really important.
Yes. Especially when you're dealing with division.
Mm-hmm.
Time scale. Wow, time looks like a stupid word now.
Yep. It's gotten to that point.
All. Save. Go.
Holy.
Okay. Well, that was wrong.
It was wrong or awesome? That's
It was
the question.
totally awesomely wrong.
Yeah. Both things. It's not finding that, by the way. Because the...
I know I didn't capitalize time.
Yeah, it's angry about that. No, it's only... Okay, it's found 6 out of 8. It might be something with the acceleration on it, but I don't know.
Yeah, we didn't write the movement, so there's a lot of stuff that's...
Yeah,
it's certainly a big movement script.
If
but,
I was going about making a time-based thing on my own, like in my own project, I would probably be writing most everything myself.
Yeah.
Just for ease of use.
Just so that you know what's wrong.
Exactly what's going on all the time. Yeah.
Oh, it actually looks like it worked that time. Okay, it is an acceleration problem. So because if I have full acceleration, it keeps going through.
I bet the acceleration is monitored or modified by time.deltaTime.
I bet you it's not modified by time.deltaTime. I think that's
so?
the problem. I don't know. Time.deltaTime.
Oh yeah, it's probably not then. Well,
so where's the velocity? That's the velocity for... Okay, that's jumping. So let's look around moving. Apply input velocity change. Yeah, I'm not... Oh, wait.
or is it...
Enforce max velocity. So that's the max velocity. That's the only place that's using it so far. Which means that... Yeah, we're missing a change here. So... Input move direction, let's see. Desired velocity, vector 3, if grounded too steep. Get desired horizontal velocity. Where is this found? We're learning about this little program, so get desired horizontal velocity. Input move direction. Desired local direction. Okay. That's the desired velocity. Okay, that doesn't help us either.
Is there anything on acceleration? Just in general?
Just search for acceleration. You want to do that. Get max acceleration. Get max acceleration. We don't want max. We want... Yeah, I think it's velocity is what they store it as. Velocity.
Oh, there's a lot of velocities.
Yes,
128 occurrences of it.
Yeah, there's a whole lot of velocities. So, desired velocity... Velocity change vector. Here we go. Desired velocity minus velocity...
Normalized velocity. Yeah, I'm not really sure why it's doing that.
Equals desired velocity... Max velocity change. Return velocity. Divided by time.timescale. Let's see if that does anything. Oh. Okay, yeah, that wasn't good. What were we doing before? Oh, we do want that. Okay, so...
I just think we should probably not worry too much about it.
All right, fine. We're not going to make the player work in it.
Hey, it works partially.
We have proof that the other thing can work. We've done circle move with this. If we replace this with our time manager dot real delta time dot real delta time. Oh, that instance. Dot real delta time. So you'll see that the sphere should no longer mess up. Yeah, see the sphere is
still going.
Still going.
Going
It's
strong.
full speed. And it should still be going slow when we get in this thing. Yeah. So that's the theory, but evidently there's more than I realized that I needed to change in places on the character motor. So
No.
I may post if we discover what actually needed to be changed, I may post the information on that. I may also post the links to those C# files that, for whatever reason, don't exist when I search the internet anymore. So, alright, so, yay, that was a failure.
Yeah, well, we got it moving fast as long as you maintain your acceleration and velocity. Which is good.
I guess we could just change it to Unreal Tournament style movement.
Where you just don't have any. Just
yeah, we'll just
all or
go
nothing.
on the first-person controller and just do movement and just be like slope speed multiplier. No. Max ground acceleration, like
Holy moly.
So
I don't think that changed it. How did it not change it?
that's the max ground oh, I know why, because yeah, it's probably due also to the input being no, I don't know. Okay, whatever. I'm done. I quit. I'm over it. What was this before? It was
20.
15,
It was 20.
It was 20?
Yeah.
That liar. It's showing it like it's changed, man. I thought it changed at least.
It's better than us moving through molasses to get out of there completely, so.
Yeah. Just molasses when you start moving in there.
Yeah, but then you're okay.
We'll call it an effect of time distortion on.
That works for me.
Yeah, that's a. Yeah.
That's a time
That's a
distortion
physical
side
problem. We
effect.
can't actually, we can't solve for that because humans, when they're in a time distortion field, will slow down when their accelerations don't work anymore for some reason.
Yeah, but if they can stay at a constant
Yeah,
motion,
they
they're
have.
fine.
You have to
Yeah.
really work through it. It's kind of like it's a viscous time. So,
Exactly.
all right. So, what else do we have that we could play with? Okay, so one of the things that we were talking about doing is a couple different methods, a couple different types of time slow. So what we've got here is we've got a couple that just slow time based on, if you're in them, it adjusts the time scale to whatever we want the time scale to be. So let's try making one that actually adjusts based on your proximity to an object. So we're going to create a new script. Now keep in mind, some of the scripts we're doing will not be strictly compatible with each other. So if you're in a time, one of these things, depending on script execution order, you'll either be affected by the new thing that we're doing or one of the other things. So keep in mind, if you're doing a lot of different things that are changing time, you can step on your own toes. So
Yeah, you have to be really careful about orders.
we have a singleton so that it does handle things nicely, but if it's getting, like, if there's scripts fighting, they're still going to be fighting. So
Yeah, you got to keep them separated.
change time scale based on distance to player. That's a lot of words.
Yeah, that's fine.
Alright, so all we're going to do on this one is in the update, we're going to player, okay, transform player position equals game object dot find Game object with tag. Player. Dot get component. We're just going to go right for the transform. Oops. Alright. And so now we just do if, or wait. Time manager dot instance dot change time scale, and we only want to set the time scale because we want the transition time to be instant in this case. So we're just going to set it to the distance of the object from the player. We probably want to cap this at some point too, but let's just play around with it real quick. So
Okay.
we'll just do it based on, so if you're a meter away, it'll be 1.0, and then if you're further away, things will move slower, and if you're closer, things will move.
No, you could cap it at 1. I mean, or set a...
Oh, if you're farther away, they'll move faster.
Yeah.
Yeah, I'm not going to cap it for right now. Let's just see how it does. So we'll do player position minus transform dot position dot magnitude. And transform dot position dot player position. Oh, wait, I don't want the transform. I just want 3 player position equals transform. Actually, we can just do dot transform dot position. That'll work better. There we go. So now we need to put this on an object. So I'm going to, where's our player? I'm going to put the object, maybe I should put it on the sphere because it moves. Just to make it more interesting, let's do that. So we're going to put time, wait, no. Change time scale based on distance player and hit play.
That one isn't being effective because it's doing real time. The real delta time.
Yeah, which is good because
This is awesome. The music didn't loop.
music doesn't loop. Music. Hello, music. Where is our music? Garbage music. There it is. Let's set that to loop.
That's awesome. To fall off the edge of the world. Alright, that's pretty cool.
Time scale is out of range. Alright.
Oh, who would have thought?
They don't allow higher than 100. That's so lame.
No, it kind of is a little lame.
Alright, so, yeah, so that does work.
So let's set a variable to cap it at.
Alright, so public float max time scale equals, let's set it to 2.0 f.
You should make the
I should make what?
the range of it larger too. You can do that.
Yeah. So public float distance multiplier equals
5.
5.0 f. Yeah, why not? We'll just start at 5. And so what that means is we want magnitude. Actually, let's make the multiplier 0.5. Actually, let's make it 0.1 f. And so all we do is we just take the magnitude here and multiply it by distance multiplier.
And I found that character motor in C#.
Oh, good, good.
You should be getting it here momentarily. It's very slow. There, character mode.
It is nice that the character motor is not.
There we are.
Like, I'm glad that we changed what we did because I wouldn't be able to move away from that sphere very well.
Yeah.
At all, so
It's pretty cool, though.
oh, we didn't put the max in.
Did we didn't?
No. So
Oh.
So we can just do math f dot max. So we just put that in as 1, and then we put the other one in as max timescale. Okay, so that's times 2, times 2, times 2. So it would be min. Let's try that.
Alright. And you can see the pitch just changing there. You're getting close to it.
Yep, it's working.
Yep. And this will fight, as you said.
Well, yeah, if we
Theoretically.
go into one of these... Okay, so it doesn't care anymore about what that one wants at all.
Yeah, it's just going about the position.
And what it'll care about is based on script execution. So whatever executes last is what it's going to care about.
Yes.
So that will depend on arbitrary things if you're not changing anything, but if you do some script order stuff, you could probably manipulate things to work as you would like. All right, so that's one more time.
Music is just
type
going
thing.
crazy.
All right, let's save this, and let's create a new scene. Actually, let's duplicate this scene so that we don't have to do as much work.
Yeah, that sounds like a good plan.
Test 2. We're going to load up test 2, and I'm going to simplify things a lot. We're just going to delete. Let's keep the garbage music. Let's keep the first-person controller, and let's
get rid of the physics object and the particles.
Okay, let's get rid of all of the objects, basically.
Yeah, it's just...
Although I want to keep the particles because it lets you. I don't know, these things. Okay, I'm just gonna get rid of these ones.
Just keep.
Yeah.
Get rid of those two things.
Yeah.
Oh, I miss
So-
them already.
One of the ideas that that Phil thought we should investigate, just because people have seen it before and it's kind of interesting and cool, is the concept of
Basically, time distortion based upon movement.
yeah. Braid has in the second level a really interesting game mechanic where basically time is not flowing if you're not moving, and if you move to the right, time flows forward, and if you move to the left, time flows backwards. Again, we're talking about time flow backwards here, but we can still implement that with what we've got here because assuming that we don't affect the player with time, which in the case of Braid, the player is not affected by time on these levels. So
Yes.
let's go ahead and look at doing that real quick.
This will,
So-
of course, not work properly for physics objects.
Yeah, this will not work properly for anything that you are not scripting yourself.
Yeah.
We're actually going to approach it slightly differently. So instead of using Time.deltaTime to drive our objects, it actually won't work with animated stuff either
Oh, really?
because we're not changing the time scale
We
at
aren't
any point.
actually manipulating.
Well, maybe we should just manipulate the time scale. But that doesn't... yeah, let's not do that.
Yeah.
So So this isn't going to work on the particles. This isn't going to work on the physics objects. So let's get rid of the cylinder. This should work. This will not work on the animation. So let's get rid of the animated one. So we're left with this stupid thing. Let's
It's the circle dude fella.
put this back. So instead of doing TimeManager.instance.real.delta.time, we're going to, first of all, I'm going to move this thing so that it's more in front of the player and a little bit further away from the player so that we can see stuff easier.
Sounds like a plan.
So we have that sphere. And we're not going to use our time manager on this. So we're just going to reevaluate how we're doing this. So part of the reason I want to do this is so that you guys don't feel attached to these systems. So like one of the secrets of everything is someone had to program everything at some point. So like even though we use the Unity physics system and it just works, someone made that, and that has a whole bunch of stuff to it. And you could probably make one of those yourself if you had the time to make your own physics system. You don't have to use theirs. Like you could plug in Box 2D, you could make your own. And you'll learn a lot doing that stuff, but like you don't have to use the built-in physics, you don't have to use the built-in animation, you can build your own components on these things. And so this is one of these cases where anything that we do on this is self-created. This is not, we're not trying to create a general solution for Unity in this one.
Yeah.
We're just trying to create an interesting way of looking at movement and time. So we're going to create a script that basically keeps track of the player movement in the Z coordinate. We're just going to basically be, in the case of Braid, it was the X coordinate. We're going to use the Z coordinate in this one. So if you move forward or backwards, you'll go forward or backwards in time. So we're going to create a new script called.
And if you move to the side, time will theoretically stay
the same. Yeah. If you don't move or move to the side, time will not move at all. So the other thing that's not going to work on this is our music. This is not going to work either. The reason this was most of the things that don't work are the things that we couldn't do a replay system for as well.
Mm-hmm.
The music, again, if we reversed it, you heard that it didn't reverse the music. Like I don't even think they keep the data that they've already read on the music thing. They probably just stream forward, which that's another thing you'd have to do if you were making your own music manager. You'd have to basically load in the file, and either if you were going to do streaming, you're going to have to like look ahead or look behind based on the so there's a lot of stuff to keep track of. So
making time go backwards is a really, really lofty challenge.
It's really fun. I mean, it's something to do. Yeah, let's just delete both of these stupid behavior scripts I made that I didn't name. Create new C# script. We're going to call this player Z delta. And I'm just going to grab this little thingy. We're going to need to have private vector3 last position. Last position equals this thing, so that it has a good starting point.
Good deal.
So we're going to need to set the last position at the end of here, and actually we're just going to use the player position so that we don't have to keep polling objects for their infos. And finally, we're going to create a public float z delta equals public called z delta, and then z delta equals player position dot z minus last position dot z.
Cool.
And then all we have to do is go into our so we're going to put this on our first person controller here, and then finally we're going to, on the sphere here, we've got the circle move thing. We want to get that delta from the player, so we're going to grab the where is it? Circle move. So player z delta, player z delta equals. We'll just grab. Bam. Doing a little bit of copy pasta here.
It's not a bad thing.
Dot get component player z delta. So now we have that instance of that script, and then we can just do time manager. So instead of adding the time here, we're just going to add the player z delta dot z delta.
All right.
So if we hit play here, our sphere is not moving. And if we move towards it, it moves forward in time. If we move back away from it, it moves backward in time. If we move left and right, it moves very little, if not at all.
It's pretty cool.
So if you wanted to create like a 2D game, you could just do this, you know, on the X side, or even just rotate everything to the side, put the camera there, and call it good. But yeah, basically you could now create a system where the objects will move based on the player's movement into or away from the scene. Now, the one thing about this is we're doing deltas. There might be a little bit of degradation because of floating point accuracy. I'm not sure how bad that would affect things in this, but it's there's a potential that if you move enough, that position that used to represent a time may not still represent that time.
Correct.
The other way you could do this is instead of using deltas, if your logic supports it, you can pass in the time exactly to get the position. And like this is an example of one where we could do that, where instead of just adjusting t by the delta, we could just pass directly the player position z position, not the delta z, but the z position itself. And that would not have that. The potential of drift due to floating point accuracy. I don't think it's going to be that big of a deal, but it might be. So if you have bugs related to that, you might want to look at being more strict about, instead of using deltas, just using the exacting position for the time variables.
Yeah.
So I think that just about wraps things up. Was there anything else you wanted to look at?
Well, I mean, for this one, you could show more of what it can do, but I think it's pretty concise what's going on here.
Let's make an enemy type thing. Let's do something where an enemy moves left and right.
Left and right, or away from you, even.
Away from us.
Yeah, so it like goes off into the distance as you're chasing after it. You run backwards, it'll come right at you.
If you run backwards, it runs at us. So it would be running away from us.
Yes.
Let's try it. Let's give it a shot. All right, so we already have a move towards player here, maybe. Does this actually work? I had this in the project. I don't even think I've tested it. Let's just make a...
Let's try it.
Yeah, cylinder. We'll call it a cylinder. And move towards player and hit play. Whoops. Oh, whoops. Let's not hit play. And then create a cylinder, and then attach the move towards player.
Oh, that would do it.
So this thing is moving towards us.
It's not based at all on...
Yeah, it's not... This thing is... Okay, so this is working the way that moves us towards us. So now instead of time.deltaTime... So this is the nice advantage of doing the deltas, is this enables us to... So if you were doing just the static thing, you couldn't have things react to the player because the state is based entirely on the time at that point. So this actually does solve that problem. So this actually allows things to interact with the environment too. So this is probably the better way to do it. This is the reason I showed it to you this way as opposed to showing it the other way first. So instead of doing time.deltaTime, all we do is... and
remember, you could use different things. You don't feel like you're stuck using the time.delta or the delta movement when you maybe think you should use the other one as well. You can always use them both.
Component delta. Wait, you could use both which and which?
In different situations.
Yeah.
just don't feel like you have to do one way all across the board. Oh, hello.
Player Z delta dot delta Z delta. There you go. So now this thing doesn't move. And if we move forward, it will start moving towards us. If we move backwards, okay. Oh wait, that thing has a time. Okay, let's get rid of that. Let's get rid of that.
I forgot all about that.
Let's turn that off.
Yeah, let's get that away.
All right, so we move forward and it moves towards us, and if we move away, it moves away.
Yeah,
and it's very scared.
Only if we're retreating.
Yeah. If we're moving left and right, if we move right, it'll come towards us. If we move left, it'll go away from us. I actually want to do something real quick. Component effects trail renderer.
All right. Well, that's pretty cool.
You can see the curvature now of what we're doing, kind of.
It's pretty neat.
Yeah, you can create some very strange and wonderful effects in games if you just think a little bit outside the box and play around with things.
Yeah.
Always play. Always give things a shot. And
the worst that happens is it just doesn't work.
Yeah. And the things that you can't get working now, you may get working later. Sometimes it's a matter of knowledge. Sometimes it's a matter of technology. Sometimes it's a matter of there's a lot of different things that can change what you can make. And so just keep at it and keep trying things. So I'm going to call that a wrap. Thank you for joining us tonight. If you want to contact me by email, please email me at pushypixels@pushypixels.com. You can also tweet me at Drakfire.
If you want to send me a Twitter message, you can do so. It's at MagmaLemur. If you want to send me an email with words in it or pictures or whatever, send me an email, philip@protosoftworks.com. And remember, you need to buy Proton Pulse. Buy Proton Pulse. Get the free version or buy Proton Pulse. It's on the Ouya, it's on the PC, it's on the Mac, it's on the iPhone. Buy it.
All right, and you should buy Automation. It's just on the iPhone, but it's totally awesome.
Thank you. And also, anyone who's an independent developer and has a free time this weekend should totally participate in Ludum Dare.
Oh, that's this weekend. I didn't even remember.
Yep.
Sweet, yeah.
Participate
do Ludum Dare.
Ludum Dare.
Just 48 hours. What else are you going to be doing this weekend? If you're doing something this weekend, obviously.
Yeah, I may or may
not going to help, but
participate due to work scheduling. But
I can never resist. I have to do it.
If you guys seriously, if you make anything, let us know. We'd love to see it.
Oh yeah. Share your stuff. We'll do a section on next Monday if there's people who send some stuff. So send us some stuff.
Yeah, we'd absolutely love to feature some of it. So I just think that that you guys should go out there and be creative, and challenge yourself with it. It's a lot of fun. Yeah, that's all. I wanted to do a quick plug for that.
All right, cool. Thank you for remembering that.
Yeah, no problem.
See you guys next week.
Have a good whatever day you're watching this.
Excellent.